students, this is the key to quiz 9. Okay, it says assume that A, X, Y, and Z and B are positive numbers and B is not 1. Use the properties of logarithms to write the expression in terms of the logarithms of X, Y, and Z. Okay, so what we're going to do here is first convert the 10th root to the 1/10th power. So that's as if it was x to the 7th, y to the 5th, over z to the 10th to the 1/10th power. Then what logarithms let you do is strip the exponent off and put it on back. So doing that lets us do this. Okay, and then we know that logarithms break up quotients into differences and products into sums, and then it'll strip all the individual exponents off of those. So that'll be 7 natural log x plus 5 natural log y minus 10 natural log z. So it broke up the quotient into a difference and the numerator product into a sum, and then stripped off all the exponents. So that's the result. These aren't natural logs, I'm sorry. They're log base b's. There. Log base b. Okay. Now we're doing the opposite. Now we're collapsing it into a single logarithm. So these numbers that are in front now become exponents. So this will be log base b of x plus 1 to the 3rd minus log base b of x plus 8 to the 4th, and then there's just a log base b of x. Okay, so these two things here will be factors in the numerator, and then that thing will be in the denominator. So it's going to be log base b, I'll put that one first, x times x plus 1 to the 3rd over x plus 8 to the 4th. You can check your answers by just using some log base and making x a particular value, like if you made x to be 3 or something. They should agree. This expression here should agree with this expression in every value of x. Okay. Given that log 10 of 5 is that, log 10 of 6 is that, use these values and the properties of logarithms to approximate the value. Do not use a calculator. Okay, well, so we know log 10 of 5 and log 10 of 6. So what we're going to do is make this to be log of 5 times 6, because that's 30. And then log of a product breaks up into a log of sums, a sum of logs. Then you just literally add these two numbers together. So that's 0.6990 plus 0.7782. So 2 in that decimal place, 9 and 8 is 17. So another 17. And then a 7 and a 7 is a 14. So that ought to be what it is. I mean, you can check your answer on the calculator. A little bit off, but good enough. Okay. Question 3 says solve the exponential equation in 2 ways, using like bases and then using logarithms. So in order to do it with like bases, we need the bases to be the same. So 9 can be written as 3 squared, so we can have this equation. Then you multiply the exponents in this, so that's 3 to the 4x. Now, since they're the same base, that means the exponents are the same. So what you could do is subtract an x. So you get x, or you get negative 4 equals 3x. And then, so x would be negative 4/3. Does that actually work? Let's see. 3 to the negative 4/3 minus 4 is that 9 to the 2 times negative 4/3. Yeah, that's it. Okay, now if you did it by logarithms, you would just do any logarithm you want to both sides. I suppose it would make sense to use log base 3 though, but it really doesn't matter which logarithm you use. So I'm going to use natural log because that's my favorite that's my favorite logarithm. So then those strip the exponents off. And then this would be 2x natural log 9. And that's 3 squared, so a 2 pops out of that as well. Then you can just divide both sides by natural log 3. And then you end up with the same equation as before. Okay, so whatever's easier, you know, is the best way to do it, I guess. But yeah, 2 different ways. Okay. To solve an equation like this, what you need to do is use log rules to combine them. So the sum becomes an internal product. I'm wondering if you could just subtract that and then cause it to be an internal quotient. Instead of doing that, I'm just going to make, so if the natural logs are equal, that means the inputs are equal because it's a one-to-one function. So distributing this x, you get x squared minus 6x equals 91. So you can just make both sides the power of e, and then they cancel out. So then you would subtract the 91. And that thing, I believe, factors into x. It's 91. X minus the 13, and then x plus the 7. Because 7 minus 13 is negative 6. Okay. So you're not allowed to, if you look at this thing here, it originally started with a straight up natural log. Neither of those two inputs can be negative. So if we chose x to be negative 7, immediately it's not in the domain of the function. It's in neither one of their domains. But then if you plug 13 in, it works. So we're only going to go with x equals 13. You can do a quick check here. Natural log of 13 And then this one would be natural log of 7. That should be the same as if we did natural log of 91. Now this says use a system of 3 equations and 3 variables to solve the problem. Okay, it doesn't say what way you have to do it, so there's a calculator way to do these that I'm going to show you. But I'll show you 2 different ways just in case you don't have the calculator functionality. So Ullman invested $24,000 in a rollover. Invested a $24,000 rollover IRA account into 3 banks, paying 5, 6, and 7% annual interest. Okay, so you need to make variables for these. So, X equals amount invested at 5%. Y equals amount at 6%. And Z is amount at 7%. Okay. You know that they add up to 24,000, so that's one of our 3 equations. Then every sentence is giving us a new equation. So, sorry about them. She invested 1,200 more at 6 than at 5. So that tells me that the amount invested at 6% is the amount invested at 5% plus an additional 1,200. So the amount invested at 6% is the same as the amount invested at 5% plus an additional $1,200. Okay. And then the total amount of interest she earned was $1,488. That means that if you actually apply those percentages to them, you get your interest. So 5% of X plus 6% of the amount invested at Y, and that gives you your interest income. So those are our 3 equations. Right? We have this system here we have to solve. So if you subtract this equation here from that one, the Y cancels out. So you would end up getting X plus Z, and then you'd have 24 minus 12 would be 22,800, and then we have to subtract an X, right? 28 and 12 is 4, so that's correct. Now you can add that X over. Well, actually, why don't we just subtract an X from it, because then we have Z isolated. Okay. With Z isolated, see how we can sub in that expression for Y there, and that expression for Z there, and then everything will be in terms of X. So we ultimately get, I'm going to multiply through by 100 just because these numbers are irritating. So 5X plus 6Y, but Y is X plus 1,200, plus 7Z, which is 22,800 minus 2X. I multiplied by 100, so this has 2 more zeros at the end. So now that's a linear equation in X that we can solve. So we get 5 plus 6, and then minus 14. Right, 5x plus 6x, and then a minus 14, so that will be minus 3x. Then we have 6 times 1,200 plus 7 times 22,800. So minus 3x, 6 plus 1200, 7 plus 22,800. So then we have plus 16,6,800. Okay, that equals the other side. So now we'll subtract that number from that number. 14,8800 minus this. So we get negative 3x is negative 18,000. So x is $6,000. Okay. Y then has to be $7,200. And then Z would be 22,800 minus 2 times 6,000. Okay. Now there's an easier way to do it in the calculator, as long as you can set this up. Let's just look at our original system here. There's a way to do it with a matrix. So if you go in here to matrix, what we need is a let's see, it's the number. Let's okay, so it made it into a 5 by 5, but we have 3 rows and 4 columns, so I'm going to call that a 3 rows, 4 columns. So each coefficient of this is a 1, so 1, 1, 1, and then the last number is 24,000. Now, if you have to subtract this off, so it would be negative 1x. Then the y have a 1, and the z, there are no z's in that line. So it would be like that. Then this one is a 0.05. Let's just multiply everything by 100. So then it would be 5, 6, 7, and then 14,8800. Okay, so now that matrix is stored in A. So if we go to matrix again, we can do math with these. And what we want is called the row reduced echelon form, so it's RREF. Oops. I don't want to be changing that. It was trying to edit that column. Let's make sure that we didn't change A. 1, 1. Okay, everything looks okay. Let's get out of here. Then go to second matrix, math, row reduced echelon form. Then we need to grab A. So second matrix, 1. And what it's going to do is, it's going to tell us these 3 numbers here. So x is 6, y is 7,200, and z is that. So we did it right, but this is easier. So as long as you the work that you would show here, if you wanted to do it that way, would be you would just say you went RREF on you went RREF on 111 2400. 24,000. Then you went negative 1, 1, 0 on 1,200. Then you went 5, 6, 7 on 1,488. 0, 0. And then that gave you the identity matrix. And then it gave you the answer. Oops. 6,000. 7,200. 10,800. You can do it that way as well. Okay, doesn't matter to me.